All right, gang, here we go. This is for Chem 2 Unit 11. We're talking about acids and bases. Specifically in this video, we're going to talk about the autoionization of water. So in the previous video, we talked all about acids and bases, how they work, so on and so forth. A couple different definitions of acids and bases. We focused on the Bronsted-Lowry definition of acids and bases, where acids are defined as proton donors and bases are defined as proton acceptors. And then we established that water is a rare substance called an amphoteric substance, meaning it can act as an acid or a base, right? Okay, and so what occurs if you have pure water, most of it is going to look like this. We're just going to have this part of our reaction here where we only have water molecules. But occasionally these water molecules will hit in such a way that they will ionize each other. One will gain a hydrogen, one will lose a hydrogen. One will act like the acid, one will act like the base, and you'll end up with ionized water. And this will happen very, very rarely. It's so rarely, in fact, that it's essentially pure water is a non-electrolyte. It won't conduct electricity because there's so few ions in there. All right, and these are just three different ways of looking at it. Now, if we were going to write out the equilibrium expression for this, because it's at equilibrium, we know that the equilibrium expression is K is equal to the concentration of the products over the concentration of the reactants. Now remember that pure substances, so solids and liquids, do not belong in the equilibrium expression. So there's not going to be any reactants in here, so just be the product. So the Kc expression for this reaction would look something like this. Kc is equal to the concentration of H3O plus times the concentration of OH minus. All right, and it turns out that at 25 degrees Celsius, this is very, very constant because it's an equilibrium. That's nice, and it's such an important value that it gets its own K expression. It's Kw, right? And so at 25 degrees, our Kw is equal to 1 times 10 to the minus 14th. All right, and it's an important number here. Make sure you memorize that sucker there. All right. Now, we can use this value and the equilibrium expression in order to determine what the ratio is, or compare the concentrations of the H plus and the OH minus. So we can establish the fact that based on that, we can figure out whether our solution is acidic, basic, or neutral. Essentially, it boils down to this idea that if the concentration of hydronium and hydroxide are equal to each other, we have a neutral solution. If the hydronium is greater than the hydroxide, it's acidic, and if the concentration of hydroxide is greater than hydronium, it is basic. All right. And so they show you here hydrochloric acid solution is acidic, so H plus is greater than OH minus. And they walk you through these other things. Now the interesting thing here is this last line here, and you see that no matter what you have, acidic, neutral, or basic solutions, if you multiply H plus by OH minus, you always get 1 times 10 to the minus 14th when you're at 25 degrees Celsius. All right, let's try this guy here. All right, it says in a certain acidic solution at 25 degrees Celsius, H plus is 100 times greater than OH minus. What is the value for OH minus in this solution? So we know that our Kw is equal to 1 times 10 to the minus 14th, and it's also equal to the concentration of H plus times the concentration of OH minus. All right, we also know from this other part here is that H plus is 100 times greater than OH minus. So our H plus is going to be equal to 100 times the OH minus. Okay, and so then we can take this value and we can plug in to solve for our OH. So we know that 1 times 10 to the minus 14th is equal to, we'll plug this in for our OH minus, so we get 100 times the concentration of OH minus times the concentration of the OH minus. All right, and so essentially to solve for this, we just take 1 times 10 to the minus 14th divided by 100, and then take the square root of that, because that times that would be squared. So that means the concentration of OH minus would be equal to, I did this a second ago, so it's still in my calculator, is 1 times 10 to the minus 8th, which makes sense that it would be less than half of the times 10 to the minus 7th, so because we know it's 100 times greater, so therefore our answer would have to be A. All right, let's try another one. All right, it says indicate whether each of the solutions, each of the following ion concentrations are neutral, acidic, or basic. All right, so essentially what we need to do is just look at the concentration, and if this number is greater than 7, then we know that it's and so this takes a second to think about, because we know that because the exponent here is greater than -7, that means we're going to have a lot more decimals out front. So we know that this concentration of H plus has to be less than the concentration of OH minus, so that means this solution would have to be basic. Now, if that doesn't quite follow, we can do it mathematically as well. We know that 1 times 10 to the minus 14th should be equal to this value here, 4 times 10 to the minus 9th, times whatever our concentration of OH minus is. Okay, so we can find the concentration of OH minus pretty easily. All right, we just take 1 e to the minus 14th divided by 4 e to the minus 9th. Okay, we get 2.5 e to the negative 6th times 10 to the minus 6th. And so we can see here that the concentration of OH minus is much smaller, or much bigger than the concentration of H plus, so it has to be basic. This guy here is 1 times 10 to the minus 7th, so this guy has to be neutral, and you can prove it to yourself by doing exactly what we just did. And then this guy here, well, the concentration of hydroxide is much smaller than 10 to the minus 7th, so therefore we have to be acidic. Well, if we did the math here, we'd find a lot more hydronium ions. All right. Let's try this one. A solution has a hydroxide ion concentration of 4 times 10 to the minus 8th. What is the value of H plus for the solution? Well, we just kind of did a problem just like this a second ago. We know that Kw, right? Kw is equal to the concentration of H plus times the concentration of OH minus. All right, if we want the concentration of H plus, we just rearrange this, so that means the concentration of H plus would be equal to Kw divided by the concentration of OH minus. All right, so the Kw is 1 times 10 to the minus 14th, and it says the concentration of OH minus is just 4.0 times 10 to the minus 8th. So we just take 1 e to the minus 14th, and go ahead and practice this on your calculator. It can't hurt. You'd feel really stupid if you were taking a test and you had the right stuff down but didn't know how to run your calculator. Real stupid. So I got 2.5 times 10 to the minus 7th. You know, I say something like that, and then one of these days I'm going to foul up on my calculator and somebody's going to comment on my video. All right, so the video's there, or the answer there would have to be C. All right, it says calculate the concentration of hydroxide in a solution in which, and we've got 3 different things here. All right, so again, we're just practicing here. This is really just like exactly what we've been doing here. So A, I'll just go, I'm not going to write it all out. You know, for A, we just take 1 e to the minus 14th divided by the concentration of hydrogen, right? So 2 e to the minus 6th, all right? So I got 5 e to the negative 9th, 5 times 10 to the minus 9th. All right, B, well, if they're equal to each other, the only way that happens is if you have, you know, that. You know, you take the square root of 1 times 10 to the minus 14th. And then for C, for this guy here, well, this is like the very first one we did. So we know we're trying to find the concentration of OH minus. So that means, well, this one I might have to do it's hard to do it. It's hard to do it under pressure. Okay, so let's see. We got our Kw is equal to the concentration of H plus times the concentration of OH minus, and we know H plus is equal to that, so that means our Kw would have to be equal to 200 times the concentration of OH minus squared, all right? And then our Kw is equal to 1 times 10 to the minus 14th, all right? So the concentration of OH minus would have to be equal to 1 e to the minus 14th divided by 200, and then you take the square root of that, and I got 7.0 times 10 to the minus 9th. All right. Cool. So we did it. So autoionization of water, pretty easy stuff, really. Just 1 times 10 to the minus 14th, and you're just solving for whichever value you're solving for. That shouldn't be too bad. So do your practice problems. Let me know if you have any questions, and I'll see you on the flip side.